A cylindrical tank is being filled with water at the rate of 4 cubic meters per minute. How fast is the height of the water increasing if the radius of the cylindrical tank is 3 meters? Let us say this is the cylindrical tank. The radius of the cylindrical tank is 3 meters. According to the problem, the cylindrical tank is being filled with water. So there is a change in the volume of the tank, and the change with respect to time is the 4 cubic meters per minute. Therefore, dV over dt is equal to 4 cubic meters per minute. We are going to find out how fast is the height of the water increasing if the radius of the cylindrical tank is 3 meters. So we are going to solve for dH over dt. We are going to write an equation related to the variables. And the equation related to the variables is the formula for finding the volume of a cylinder. And this formula is V is equal to pi r squared h. Before differentiating both sides of this formula, we must first substitute 3, the length of the radius of the cylindrical tank, because in the problem 3 is constant. It is constant because the cylindrical tank in the problem will not increase or decrease in size. So the radius of the tank will remain the same. So we have now V is equal to pi times 3 squared h. This is now V is equal to 9 pi h. Let us now differentiate both sides of the equation. So we have now dV over dt is equal to 9 pi dH over dt. And then we substitute 4 for dV over dt. So we have now 4 is equal to 9 pi dH over dt. And then we solve for dH over dt by dividing both sides of the equation by 9 pi. So we have dH over dt is equal to 4 over 9 pi. And this is equal to 0.1415 meters per minute to the nearest 4 decimal places. This is how fast is the height of the water is increasing if the radius of the cylindrical tank is 3 meters.